In the 1920s, a single Bucer steam shovel could move as much earth in an hour as 100 men. Its 150 horsepower engine reshaping landscapes that once took months of backbreaking labor. Whole cities and highways rose in a decade as machines replaced muscle, forever tipping the balance of power at the construction site. But how exactly did these mechanical giants seize control of civilization's progress? The answer starts where human limits stopped, beneath the dirt, at the dawn of the machine age. Down in the pit, the Bucer steam shovel stood as the king of earth moving. Its steel bucket, sometimes 5 cubic yards in size, swung out on a boom powered by a 150 horsepower steam engine, biting into the ground where men with shovels once toiled shoulder to shoulder. The engineer, perched high in the cab, worked the levers with practiced hands while the fireman kept the boiler roaring with coal. A third man, the groundsman, watched the swing and signaled for safe digging. Just 3 men commanded a machine that could move 200 tons of soil every hour. More than 100 laborers with picks and wheelbarrows could manage in a day. Each scoop filled a waiting rail car, the cycle repeating every half minute, the rhythm of industry echoing through the cut. The shovel's appetite was relentless, coal in, earth out, day after day. Downtime meant lost time, so the crew kept a close eye on steam pressure and gears, knowing that every hour of work from the Bucerus meant weeks shaved off a project. Where once it took armies of men to dig a foundation or carve a canal, now a handful of skilled hands drove progress forward, letting the iron giant do the heavy lifting. The ground itself seemed to yield to the will of the machine, and with each load swung skyward, the future of construction changed forever. Across the open fields and muddy cuts, another breed of machine took command, one that did not just dig, but shaped the very ground itself. The secret lay in the tracks. Holt Manufacturing and CL Best were locked in a fierce rivalry, each determined to solve the age-old problem of soft, sinking soil. Their answer was the track-type tractor, with steel plates linked together to spread weight wide and low. Where wheels would bog down, these crawlers floated over mud, pulling loads that left horses floundering. By the early 1920s, these machines packed anywhere from 30 to 75 horsepower under the hood. A Caterpillar 60, weighing in at 10 tons, could put 12,000 pounds of steady pull on the drawbar, enough to outwork a team of 30 or 40 draft horses and keep going all day without tiring. On a good shift, a skilled operator could grade or plow 5 to 10 acres, a task that would have taken days by hand or with animal teams. The real breakthrough came when someone bolted a heavy steel blade to the front. Suddenly, a tractor could not only pull, but push, leveling ground, clearing stumps, carving roads out of wild country. That simple blade gave birth to the bulldozer, a tool that would shape farms, highways, and cities. Marketing men took these new machines on the road, staging pulling contests and stunts, showing off the raw might of tracked power to crowds of farmers and contractors. The message was clear: the age of muscle was giving way to the age of steel and gears. High above the city streets, the real daredevils of the 1920s weren't in the circus. They were iron workers and riggers, guiding tons of steel into the sky. At the heart of this vertical race stood the derrick crane, a lattice of steel and cable anchored to the skeleton of rising towers. These machines, powered first by steam and then by new electric motors, could hoist 5, 10, sometimes 20 tons at a time, enough to lift a locomotive or a spire section meant to crown a skyscraper. The reach stretched 100 feet or more, the boom swinging out over open air, with nothing but a whistle and a wave to signal the next move. On the Chrysler Building in 1929, the spire itself was assembled in secret inside the tower, then hoisted in sections by derrick and rigging crews working through the night. Each piece, weighing several tons, was lifted over 70 stories above Midtown. No safety nets, just balance, nerve, and the steady hand of a foreman calling signals. The crew worked with steel guy wires anchored deep into the frame, each cable tensioned to keep the mast steady against sudden gusts. Every lift was a test of nerve and calculation. A slip could send a beam or a man tumbling to the street below. By the decade's end, truck-mounted cranes began to appear on job sites, bringing new mobility to heavy lifting. But up in the clouds, it was still the derrick, steam or electric, that made the skyline possible. The cranes didn't just move steel, they moved the city itself, one lift at a time, as men and machines reached for heights that once belonged only to dreams. On the city's edge, the road crew chief checked his watch as another 8-ton steamroller hissed to life. The workday started early, with engines stoked and water boiling before sunrise. These machines, weighing anywhere from 8 to 15 tons, pressed new gravel roads flat with a force that no team of men could match. The compaction was more than just weight. The steamroller's smooth drum delivered steady, even pressure, squeezing air from the earth, locking every stone in place. Where gangs of laborers once swung tampers and rakes, now a single roller passed over the surface, binding the roadbed tight in hours, not days. Behind the roller, the grader moved in slow, deliberate sweeps. Its long steel blade, angled just so, shaved high spots and filled low ones, creating a crown that would shed rain and stand up to the pounding of wagon wheels and trucks. A skilled operator could shape a mile of rough ground into a smooth, cambered highway in a week, a task that used to take a whole crew with picks and shovels. Then came the asphalt paver, laying down a black ribbon at a steady pace, its heated mix spread and leveled as it rolled forward. Teams could finish 1 or 2 miles of new road every week, a pace that would have seemed impossible a decade before. The road chief watched as the machines worked in concert, each doing the job of 100 men. He knew the numbers: a finished roadbed, compacted and graded, ready for trucks, cars, and commerce. The ground, once a barrier, now opened up, feeding raw materials from mines and farms toward the factories, binding towns together in steel and stone. The age of the hand tamp was over. The age of the machine had paved the way. Deep below the surface, a different breed of machine chewed through rock and coal where pickaxes once rang out. Pneumatic drills hammered away, driving holes 10 to 20 times faster than any man with a hand auger. The mine mechanic, sleeves rolled and lanterns swinging, kept these drills running hot, swapping bits, clearing jams, and listening for the sharp crack that signaled a fresh seam. Overhead, continuous mining machines rumbled forward, tearing out veins of coal and sending it straight to waiting carts. Ore crushers thundered in the dark, breaking down boulders by the ton, work that once took days now finished in a single shift. Not all the action stayed underground. Out at the harbor, the Corps of Engineers watched over floating giants, clamshell and dipper dredges with buckets big enough to swallow a horse and engines that roared with more than 200 horsepower. A single sweep could lift 3, 5, even 10 cubic yards of mud and silt, clearing shipping lanes that fed the nation's factories. Suction dredges, self-propelled and stubborn, gulped thousands of cubic yards every day, reshaping rivers and keeping ports open for the endless parade of steel and grain. These machines formed the raw material pipeline, coal, ore, gravel, and silt, feeding the fires of American industry, all kept moving by the grit of mechanics and engineers who knew that a jammed drill or stalled dredge could choke off the country's hunger for progress. Inside the factory, the real muscle came from presses that could flatten a steel plate or shape a car fender with a single thunderous stroke. Some of these giants packed 100 to 500 tons of force, powered by electric motors ranging from 10 to 200 horsepower. The foreman, sleeves rolled up, kept a sharp eye on the line. Every machine, every worker, every moving part. On a good day, the assembly line ran smooth as clockwork. each station feeding the next, turning out finished goods at a rate that would have stunned the old craftsman. Productivity soared, 3, 4, even 5 times what hand labor could manage. But the power came at a price. Gas engines burned through 15 to 30 gallons of fuel for every 8-hour shift. Motors ran hot, belts wore thin, and breakdowns could grind the whole operation to a halt. The maintenance crew worked in the shadows, wrenches in hand keeping the presses oiled and the gears turning. Every 50 or 100 hours, the line had to pause for repairs, a reminder that even the strongest steel had its limits. Yet the payoff was plain. Factories could cut costs in half, sometimes more, and deliver the goods that built a modern nation. Today's machines dwarf their ancestors in brute force, but the leap that began a century ago still echoes in every modern build. The real legacy is this: once machines replaced muscle, there was no turning back. Progress keeps moving Earth, whether we're ready for it or not. Thanks for watching.